Hi everyone, Assalamualaikum. So today in this video we are going to talk about reliability tests. So when do we conduct reliability tests? We conduct reliability tests before we collect our data. This is because testing for reliability is very important before you use the scales. Okay, whenever you adapt the scale or you adopt a scale or even if you create your own scales, you still need to check for the scale's reliability. This is to ensure that the items used in that particular scale hangs together or actually measures the same underlying construct, right? We're going to talk about the threshold for reliability test. The common threshold is going to be alpha should be more than 0.7 as according to Develis 2012. I believe Hare also suggested an alpha of more than 0.7, but if your alpha is lower than 0.7, probably it's going to be 0.6 and above. You can definitely find scholars that supports that alpha threshold. Probably it's unique for your scales or it's unique for your own research project. It depends on the research study itself. But the general convention is that more than 0.7 is already good enough. But your alpha scores cannot be close to 1, as in it cannot be more than 0.95. That's going to indicate that you have items that is actually repetitive or it's actually the same thing. Okay, it's actually measuring the same thing. So this are the alpha threshold that I was talking about. So this indicates poor reliability, but of course it depends on your study. As you can see over here, 0.80 to 0.95 is a very good reliability, and an alpha that is too high may raise suspicions. Okay, so this is according to Zygmunt. You can also refer to Hare, you can also refer to Develis, you can also refer to other statistical scholars. Right? So I'm going to show you an example of how do we conduct a reliability test. We conduct this according to our scale, so don't chunk all of your scales together. If you, for example, if you have 30 items measuring five different variables, right? Don't chunk all your items together, but instead you need to do it per variable. This is because that item measures a specific variable. So if you chunk all together, it doesn't make any sense at all, right? So you click on Analyze. First, I'm using the survey number 4 dataset. You can find this in the Google Classroom. Click on Analyze, go to Scale, go to Reliability Analysis, right? So why am I doing this before I'm talking about the inferential statistics? Well, it's because these are the analysis that you need to conduct before running your descriptive, before running your inferential. So you run reliability tests first. Okay, and then you click on statistics. You want all of this items here, item, scale, scale if item is deleted. Into item, we want both, right? And then just click continue. You can name the label. So, okay, no worries. So here are our results. So this is what we want to see. Okay, you can take a look at the case processing summary and see whether all your cases are correct. It's true whether your n equals to 36 or 39. Okay. Let's take a look at the Cronbach's alpha. So we have a very good Cronbach alpha of 0.89, and number of items is 5. Definitely we have 5 items for the life satisfaction scale. Okay, the mean score is also given here, and these are the inter-item correlation matrix. Okay, so let's take a look at the item total statistics. You have here, this is very important over here, Cronbach alpha if item is deleted. Say for example, your Cronbach alpha is not 0.89, probably it was 0.67 or something. You can take a look at the list here under item total statistics. Take a look at the Cronbach's alpha if item is deleted, and you can see whether if you delete one item, it can increase your alpha scores or not. So normally if you have a negative inter-item correlation, corrected item total correlation, it tells you that you have probably have an item that is reverse coded, but you didn't reverse code it. Okay, so if you have a negatively worded item and you did not reverse code that item and you just simply runs reliability test, it's gonna show. All right, and it's gonna mess up with your reliability scores. So that is all for reliability test. It's fairly easy. If you have 5 variables, you conduct 5 times of reliability analysis, right? Reliability scores. So you can see here the corrected item total correlation. If it's lower than 0.3, then that particular item is measuring something different than the scale as a whole. Okay, so you can see over here. So let's try another example. So again, so we don't want to test the life satisfaction. Let's try the optimism. Okay, the optimism score. From the scale itself, I know that some of the items are reverse coded. How do I know? You need to go back to the data itself. You need to go back to the survey questions and see what questions are reverse coded. Okay, so in this data, I already know that our optimism 2, 4, and 6 is actually reverse coded. So I need to remove 2, 4, and 6 and replace them with the reverse coded R2, 4, and 6. So everything is still is already ticked. So this is not life satisfaction, but this is optimism. You have a Cronbach alpha of 0.797, which is good enough because it's already more than 0.7, right? It's already more than 0.7. So let's take a look at the item total, corrected item total correlation. Everything is more than 0.03, 0.3. And if you don't need to drop anything to increase your alpha because your alpha is already, your Cronbach alpha, your inter-item correlation is already good enough. So that is all for reliability analysis. How do we write down a reliability analysis? This is how, okay. Typically it's reported under method section, of course, because it should be under instrument development. Okay, you need to show that the instruments that you use are reliable, and after describing the scale, include a summary of reliability information reported by previous authors. Okay, so for example, it's like this. According to previous authors, the satisfaction with life scale has good internal consistencies with Cronbach alpha of 0.85. In this study, the Cronbach alpha coefficient was 0.89. Okay, thank you.